Hey guys, welcome to Basic Electronics lab on PNPs and NPNs. We're going to start with the NPN. First we'll give you a look. This is a NPN, and you can probably see the numbers on there. I believe it should be a 3904. And here is a PNP. Identical looking, just has 3906 I believe on there. Now these are actually small PNPs and NPNs, and they come in different packages that can take more current, and I know I've been referring to current as amps and milliamps, and the reason why I was doing that is most of the power supplies and stuff you see out there will talk about current and amps and milliamps, but I'm actually going to refer to it as current as well. So these may take like 100 milliamps, be capable of 100 milliamps, which is just a couple of LEDs. There are much more powerful ones, and channel MOSFETs, you know, for motors and stuff like that. We'll get to that in future tutorials, but we're going to use these small ones in this particular tutorial. There's a link below in the description to purchase some. They're a little better, the PNPs, in the link below. These are some old ones that I had that we're going to use for this tutorial. Okay, let's get into testing. We're introducing, you know, besides the PNP and NPNs, another new device to this, which is a switch. Now, we have this switch. You may order one and get it in the mail and say, well, what's with these 4 prongs? And I see the button on top, but how do I use this switch? Okay, we're going to assume that we don't know how this is set up. I know this switch, but so what I'm going to do on my multimeter, I'm going to go over to continuity testing, which is that little red one with the sound symbol underneath it. And just let me mention, I noticed in one of my earlier videos, I was actually incorrect. When we're testing current or amps or milliamps, anything under 200 milliamps, we want the red in this one. And from 10 amps or 200 milliamps up to 10 amps, we want for testing current in that one. I just thought I'd point that out to you. But right now we're going to test continuity. So we have our little switch, and if you notice on the switch, there is these 4 little legs, and so we're going to test the ones bent toward each other right now. So we have a bend out this way, a bend out this way. So we're going to test that leg to that leg on the continuity tester. And as soon as I put those in, you'll notice we get a beep. That tells me that these are connected. Now, if it was a push button normally closed, meaning if I pushed it, it opened the circuit, then it would be a push button normally closed. But it's not. I know I bought this as a push button normally open. So what that means is these two are connected together. Now, if I test the opposite ends, I should get the same result, that those two, and they're connected together. I push the button, nothing happens. Which now means if I test these ends, this one and this one, this should be my switch. So let me connect here and here. And notice we're not hearing anything. Now I press the button, and we get connectivity. So that's my switch. Okay, so now that we know that, let's actually place this on our breadboard. Here's our breadboard. Here are the 2 ends that we want to use for our switch. Now, there's a little trough, gully, routed area here. That's where I'm going to put the other 2 that we don't need. I could span over, but I'm not actually going to use them over on this side, so I'm going to leave them in the little trough or gully over here. And the other 2 ends I'm going to put into G4 and G6. So there we go. We have G4 and G6 for our little push button. By the way, if you didn't watch the previous tutorial, we're actually building this circuit, which is the NPN, and then we're going to build the PNP. So first what we're going to do is we're going to build this right here. The power supply, which is already connected, the diode, the push button, and the capacitor. So we're going to build this row first. Then we're going to come over here, we're going to build this row, and then we'll connect these together. Oh, by the way, NPN, how you remember this switch is no power, no power. So if there's no power on this leg, then there's no power going through here. This is the switch, B is the switch, C to E, the collector to emitter, is where the power flows. Now, if there's power on this switch, it's allowing power. If there's no power, then you have no power here. NPN, no power, no power. That's how you remember that. And a PNP is the opposite. Power, no power. With a PNP, if there's power here, it shuts it off. But we'll get into that when we build that circuit. Let's build this one first. Okay, so we have our switch. The next thing we need is a protection diode. We're dealing with capacitors, so we definitely want a protection diode. Now, if you notice, our positive is actually in 1F on our board. So we're going to go into row 1 with our power diode, which is this guy. Remember, this side is positive. The one with the silver stripe goes towards the negative. So we're going to put him in 1H, and then we're going to put him into the top of the power rail. So now we have power, we have our diode, and now we have the power rail. Okay, now we need the next on our list. Okay, so we have our switch. So now we want to connect the power after the diode to one end of the switch. So I'm going to take a red wire, just to indicate that we're coming from the positive, and go from the positive rail over to, we will connect it to 4J. See, that whole row is connected. That whole row there is connected. So that's that side of the switch. On the other side of the switch, we have our capacitor. Now we're going to use a 10UF. So we have the power, the diode, the switch, and then we have our 10UF capacitor, and we have a positive side and then a negative side that goes, a positive side and a negative side that goes to ground. So on the other end of the switch here, we're going to take the long end of the capacitor, which is positive, the short end is negative, as well as you can see the little negative symbols there. You know, if you're using this, if you pull this out of another board and you want to use it, or the legs are too close together and you're not sure, there's a negative symbol. So we're going to go from the positive, we're going to go from the positive side of the capacitor onto the other end of our switch. Let me see if we can get so we can see that. After I put it in, I'll display it better for you guys. So we're actually going to put it in 6H. So we're going to go from 6H, and then we're going to come over to this side, and we're going to put it in 9E. So 6H to 9E. Now we need to connect it to ground. So we're going to take a black wire, and we're going to go from the negative side of the capacitor over to our ground rail. So this actually, now I'll bring it in close so you can see, and I'll rotate it so you don't miss anything if something's being blocked by the camera. Okay, so that completes the first portion of our circuit. Oh, sorry. That completes the first portion of our circuit here. Now we want to build this portion of our circuit. So if you remember, our NPN is EBC with the flat end facing you. Everybody, enjoy baked cookies. Enjoy baked cookies if you needed an acronym for that. So let's take our NPN, and you see it here. With the flat side facing us, it goes EBC. Now if we look at our schematic, we see C is on the positive side, E is going to negative, and B, of course, is in the middle. Here, EBC. So what we're going to do to face this on here, we're going to give ourselves a little bit of room just so you guys can see, is we're going to face this, so the C needs to be up top. So we're going to do like a waterfall where it flows from positive to negative. So the face of this is actually facing the power. The flat end is facing the power rail. And so that in 10J is the C, and 11J is the B, and in 12J is the E. So that's there. Now we need to connect 10, row 10, which is our C, our collector, to the power rail. So I'm going to take a red, this time, actually I'm going to, yeah, I'll keep it there. I'm going to take a red wire and I'm going to plug it into 10I and then into our power rail. See, 10I into the power rail. So that is actually the collector, C. Now, on the negative side, we want to go, so we've gone to power, to our collector. Now we want to go E to our resistor, to our LED to ground. So we got a 470 ohms resistor here. So I'm going to take a 470 ohms resistor, and I'm going to put it in row 12, which is where the emitter is. And I'm going to put it in 12I, and then I'm going to bring it down to 18I. So now we've gone from 12I to 18I. So we're on the E portion of our NPN and 18I here. Now we need to take our LED. Now the positive, now there was no polarity as far as the resistor was concerned. There is polarity on the LED. And the longer end goes towards the positive, the shorter end goes to the negative, and if you don't have the ends, if you can't see which is longer, on the negative side, where the short is, there's actually, if you feel along the edge, the top edge, there's a flat side on the LED. So we're going to go from, we're going to plug this into 18H, and then 18E. So 18H to 18E. And our resistor is in 18 as well. That's how it's connected. Okay, so we need to continue on. We'll take another black wire, because now we have to bring this LED to ground. Now what I could do is, I could actually take this LED and I could plug it into the same line up here as the negative side of the capacitor, or I could plug it directly into the ground rail over here, which is the same. It's identical. These are both going to ground. And the reason why I'm saying this is because you'll have one ground plane. When you see your circuits, there'll be one ground plane that goes, you know, throughout your circuit board, throughout your printed circuit board. And anything that needs to go to ground, you just connect to that ground plane. So I could connect this up here to the negative side of the capacitor, and then it goes to ground. Or I could even connect this negative side to this negative side, the negative side of the LED to the negative side of the capacitor, and then put them both to ground. It doesn't matter. It's all the same ground plane. So we got that. So basically we just finished this portion right here. So we've gone from power through the NPN, through the resistor, through the LED to ground. So now we need to, so the only connection really left for us to make is our connection of our 22K resistor that goes from the positive side of the capacitor over to the B portion, or the middle leg of the base of the NPN. So let's do that now. And so we take a 22K resistor, and it needs to go from, if you notice on here, there's one portion of the switch and the positive. So in one rail on this breadboard, we have one side of the switch plus the positive of the capacitor. And now we're going to put the resistor in that same row, and that is row 6. So we're going to go from row 6, and we're going to do I6, which is open, and we're going to go to I11. So from I6 to I11, which is the B. And hopefully you can see that. I6 to I11. Now that should complete our circuit. And I'm just rotating this to, and you can hit pause if you need to view where anything is plugged in. So we went from I6 to I11. And that should complete our circuit. We should be done. Now, before we plug it in, if you remember me saying in one of my earlier tutorials that, 99% of the time, if a circuit doesn't work, it's us. It's not a component. This is actually a small circuit. We're going to build some really big ones. This is actually a small one. So, and I've actually, this is the second time I shot this video. The first time I shot it, I made a mistake, and I didn't reshoot it because of the mistakes. I reshot it because I didn't have these available. And instead of you guys having to refer to the previous video, hopefully you took notes and you wrote out the circuit from the lecture, and you wouldn't need that. But I wanted to include that, so that's why I redid it. Okay, so we built our circuit. Now I'm going to take a look and make sure that it is what we want it to be. So we need power through the diode, and everything is connected after the diode. And so then we go to the switch, to the capacitor, to ground. And I look, and let me get something to point. Here's a pen. We have the positive power. Then we go to through the diode to the power rail, and then from the power rail over to the switch. And then on the other side of the switch, we have the capacitor, which comes over to here, and then goes to ground. So that's good. The second set of the circuit comes power, diode. Now off of the power rail to the C portion of our NPN, which it does. Okay, so let's connect the circuit. And what happens when we connect the circuit is the LED should be off. And then when we press the actual power button, the LED should come on. But actually, so let's review that. So what can we expect when we connect this circuit to power? Well, what's going to happen is, right now, nothing. This guy is open, so he's not making a connection. This power can't flow through here because there's no power here, so it's not allowing power to flow through here. So when we connect the circuit to power, nothing should happen. When we press the button, this capacitor fills. That puts electric pressure onto the base of the NPN, which then it switches this on, so between the collector and the emitter, so then power flows through the LED all the way to ground. So let's try that out. So we just plugged in our circuit and we have no light, which is what we expect. Now when we press our little button, we have light. Now when I let go of the button, the light stays on. Now how does that happen? Why does that happen? If you notice, it stays on a lot longer than when we were trying to power the LED with the capacitor. This is only a 10 UF capacitor, so it stays on a lot longer. So what's happening here with this circuit is this capacitor fills up, and when we let go of the switch, it is still keeping pressure on this switch here, which allows the battery to power the LED. Now slowly the capacitor drains through the NPN and out to ground. It's not powering the LED. If it was powering the LED, you would see it go out very quickly, just like you saw in our earlier labs. So it's actually not powering the LED. But it's keeping the switch on for a little while till it drains. Now, if we put a larger capacitor here, then this light would stay on a lot longer. So let's, like I said, but this is a small capacitor we're using right now. You notice I let go of the button, and slowly it will dim. And it dims. But if I took a larger capacitor, like 100 UF, and I'm not going to replace that right now. That's a 10 UF. You can replace that later on. I'd like to move on with the other lab. But you'll see it lasts a lot longer. You know, actually, let's just do it. So I took out the 10 UF capacitor, I'm putting the positive side back over to H6, and then the negative side into E9. So now we have a larger capacitor, and usually you would disconnect the power before you did what I just did there. But anyways, here we go. Now we press it again. Now this should actually stay on 10 times longer. Now this is a 100 UF capacitor compared to the 10 UF capacitor, electrolytic capacitor. We have a 1000 UF capacitor as well. But That one I'll actually allow you to try on your own because that's going to take too long to dim. And we want to move on to our next circuit. Hopefully before the battery on this thing runs out. Okay, so let me put this down. Let that capacitor drain. As you notice, it's taken a while to drain. It's a 10 times larger capacitor than the 10 UF, the 100 UF. Okay, now let's look at our second circuit that we're going to build. It is basically the same as the first circuit, except you'll notice E and C are now turned around. On the PNP, it's actually turned around, and you'll notice, like I said in the lecture, there's the little arrow. The arrow is always on the side of the emitter. Same thing here. See, it's C and E, and see the arrows on the side of the emitter. That's how I know the difference between these two. You're also going to notice a resistor here. And like I explained in the lecture, the reason why we have that resistor here is because when there's power here, it shuts off this switch on the for the PNP. That's what we're doing next. It shuts off this switch on the PNP, and so it doesn't drain through the transistor. It doesn't drain through the transistor. So what happens is we need to put another capacitor here in which allows the power to drain, so slowly this light will come back on. Once we configure the circuit, what we can expect from this one is as soon as we plug in power, this light comes on, because there's no pressure here to turn the light off. It's the opposite of the NPN. Okay, so what do we need to do for this circuit? Well, the first thing I'm going to do is I'm going to disconnect the power, and I'm going to put back our 10 UF electrolytic capacitor. And the positive side goes into H, and the negative side goes into E. Now, if you flip this around, you got to be careful. Don't flip these around, because they can explode. Okay, so now we also need to add this resistor. Now, on occasion, I've seen this circuit not work because I've seen people add it. Instead of adding it to where the switch in the positive side of the capacitor on that rail, they've added it on the other side of the 22K resistor down. And what that does is it drains the power before it puts any pressure here. So the light never actually shuts off when you press the button. So I'm going to add the 100K resistor. And I'm going to put the 100K resistor. Actually, what I'm going to do is the 22K resistor, I'm going to move over. It's in I6 right now. I'm going to move it over to J6. So the 22K is in J6. Now the reason why I'm doing that isn't because it needs to be there for this circuit to work. It's because I need the room for my other resistor. And although allowing these to touch one another is not bad because they're on the same rail, I'd still like to be able to, you guys to be able to see it. So basically, now I want to take this and I want to put this 100K resistor there, and I'm going to put it, so I'm putting it in I6. And then I'm putting it into E11. I6 to E11. And then I want to take another black wire. Now, once again, I could connect this one directly to ground. I could connect it over here to the LED, the negative side of the LED, the negative side of the capacitor. It's all the same ground plane, but I'm just going to connect it directly to ground. Now in the future when we build circuits, I may actually take this and put it right in here. You know, move this capacitor over one and then put that in there. And it'll still go to ground. But just so now I'm keeping them separate. Just for now I'm keeping them separate. Okay, so now we have that. We also need to remove our NPN and place in our PNP. Now this is actually going to face the opposite way. If you look here, the PNP and the NPN, if they're facing you, they're both EBC. EBC. But we need, for the PNP, this is the PNP circuit, we need E to be on the positive side and C to be on the negative. Where for the NPN, we needed C and then E. So where our NPN was facing the ground rail, this, with the flat side facing the ground rail, this is going to be the opposite. So facing in towards our circuit, we're going to have plug it into 10I, 11I, 10J, 11J, and 12J. And as you can see, now it's facing the other direction. Instead of facing the positive rail, it's facing the ground rail. The flat side is facing the ground rail. So now it's plugged in the exact opposite. So now we have the emitter, the base, and the collector for our NPN. And what happens when we plug this circuit in? This light should light up. It's the opposite. No pressure here, the light lights up. When we press the switch, then this capacitor fills. It puts pressure here and it shuts off this switch. And the capacitor does not drain through the transistor, so we have to give it an alternate route to drain through, which is through this 100K resistor. So let's see if we've put this together right. We put power in and boom, the light comes on. Actually, before we do this, let me go over this. Zoom in on this a little bit so you guys can see. Turn it. You know, feel free to hit pause so you can see how these things are plugged in and what they're plugged into. Once again on this side. Okay, so we plug in our power correctly and our light comes on. Now when we press the button, we expect the light to go off. And press, and the light goes off. We let go, it comes back on. Now notice, see that 100K resistor? I think it's draining it just a little too fast. It's almost instantaneous. So we want that light to stay off longer. So remember earlier what I said, and I'm going to disconnect the power right now. If we increase this, like we're going to put in a 1,000,000 ohms resistor, which is 10 times 100,000 ohms resistor, and so the light should stay off 10 times longer. I could also use a larger capacitor, which would drain slower. But right now we're just going to take a 1,000,000 ohms resistor. I'm going to put one end in I6 and the other end in E11. Now we've got a 1,000,000 ohms resistor in there instead of that 100. A light comes on. Now I press the button, the capacitor fills. Now I let go of the button, and it takes longer for it to come up. But it's still coming up. It's still coming up fairly quick. So the next thing I'm going to do is I'm going to take out that 10 UF capacitor. This is a 10 UF, and I'm going to put 100 UF in there. So I take out the 10 UF, and remember these have polarity. The long end I'm plugging into column H, row 6, and then the short end is going into 9D, or the negative end. Now, once again, we will plug in our circuit, and the light comes on, because there's no pressure on B, and if I push the button, and then let go, now, see that capacitor's filled and it's draining a lot slower. It's 10 times the capacitance, and we've got 10 times the resistance because we got a 1,000,000 ohms resistor. Now it's coming back on. And feel free to play with these components. Change out some of these components. Don't worry if you blow up a PNP or an NPN. You know, this is how you learn. This is part of the learning curve. So once again, now the light is coming up, and coming up bright. And I think I've gone through everything here on this tutorial. We haven't measured any of the voltages or anything going through here. I'm not sure whether we're going to do that or not. But for now I'm going to hold off. And once again, this is our circuit. Now this is with the 1,000,000 ohms resistor and the 100 UF capacitor. There it goes. Now on our next video, what we're going to do is we're going to create a nightlight. We're going to create our actual first circuit, and in parallel we're going to work with microcontrollers. We're going to start you'll notice that these are channels. This is the basic electronics channel. I'm also going to have a Arduino microcontroller channel, and all the circuits that we build with the electronics we're actually going to start building in the on the microcontroller too. And we're going to talk about pull up and pull down resistors, and we're going to start doing sensors, and we're going to start doing all kinds of fun stuff. So once again, this is the last look here, and I look forward to the Nightlight lecture and then the Nightlight lab. Thank you for watching. I hope you've enjoyed, and I hope you join us for our future videos.